Today's lesson is for Course 2, Lesson 5.5 on similar figures. Get your notebooks out and get ready to take some notes. So two polygons are similar if two things are true. One, they're similar if corresponding angles have the same measure. So what that means, corresponding angles are angles, if you took the two shapes and put them on top of each other, the angles that would be in the same position. So for example, angle C and angle D are corresponding angles. And then angle A and angle O are corresponding angles. And then the last set of corresponding angles are angles T and G. And those are corresponding angles. The other thing is that the lengths of corresponding sides form equal ratios. And what that means is that we're going to multiply or divide by the same number. So in this triangle here, CA corresponds to DO. And if we look at the side length of CA is 8 centimeters, the side length of DO is 16 centimeters. We multiply by 2 to get that new side. All the sides then should be able to be multiplied by 2 if these are similar. So AT corresponds to OG. And we go from 8 to 16 again, which we are multiplying by 2. Then the final side is CT and DG are corresponding sides. In those sides there, again, we multiply by 2. So the ratio for this is times 2, where all the sides are 2 times bigger in DOG than CAT. So they would be similar triangles. So how do we use this? We can use the properties of similar polygons to help us find the missing lengths of polygons by setting up a proportion. So remember yesterday, before we set up proportions, we made a little key to help us remember where we were going to put things. So we have triangle CAT and then triangle DOG. So corresponding sides for the triangles, all the sides for triangle cat will go in the numerator and all the sides for triangle dog will go in the denominator. So what we're looking for is the length of this side right here, CA, which is X centimeters. So we will put that in the numerator because that comes from triangle CAT. So what side in triangle DOG corresponds to that? That would be side DO. So we're going to put that in the denominator. These here are corresponding, in the first fraction, they're corresponding sides. Now we look at the triangles and we pick another side, and we want to pick corresponding sides that both have measurements. So we could pick CT, which is 32, and DG, which is 40. So 32 would go in the numerator because it comes from triangle CAT, and 40 would go in the denominator because it comes from triangle DOG. And then we just follow our recipe for solving proportions. We're going to cross multiply and set the cross products equal to each other. So x times 40 is 40x, and 50 times 32 is 1,600. Now we're going to solve. So we're going to divide by the coefficient, which is to divide by 40. 40x divided by 40 is x, and 1,600 divided by 40 is 40. So the length of side X is 40 centimeters. Okay, now let's try this one. This one here is a little bit trickier because the trapezoids aren't set up in the same position as the triangles were. It's flipped. So we're going to have to think about where the corresponding sides are. So we'll take D, E, F, and G, and that trapezoid will be in the numerator, and then L, M, N, O will be the trapezoid that goes in the denominator. So let's see, what side are we looking for? We're looking for this side right here, MN. Well, that side is labeled X. That's going to go in the denominator because it comes from trapezoid LMNO. What side corresponds to that? It's the bottom side of the trapezoid, the longer side, the longer of the two sides that are parallel. So that from trapezoid DEFG is 10. Then we pick two sides from the two trapezoids that are corresponding. So we can say the side that connects the two right angles, LM, which is 6, that's going to go in the denominator. And then this side right here, DE, corresponds to that, and that's 3. So now we're going to solve the proportion. We're going to cross multiply and set the cross products equal to each other. So 3 times x is 3x, and that equals 10 times 6, which is 60. So to solve, we divide by 3. 3x divided by 3 is 1x, and 60 divided by 3 is 20. So that means the length of x is 20 units. All right, here's some story problems with similar figures and proportions, and it helps when we do these problems to actually draw a picture. So we have a 6-foot-tall person standing near a flagpole. So here's our flagpole, and we have a 6-foot-tall person. So here's our person. Okay, not really drawing to scale here. I should probably make the person a little smaller. Okay, so we need to label the measurements. We know that the person, so the length of the person here is 6 feet. Your flagpole casts a shadow 4.5 feet. So the shadow that this person casts is 4.5 feet. That's his shadow on the ground. And if you look at this, it makes a right triangle. So now we have a flagpole, and the shadow of the flagpole casts a 15-foot shadow. So that means that this length here is 15 feet. And they're asking us, what is the height of the flagpole? So this is what we're trying to find here. We have two right triangles, so we can set up our proportion. The height of the flag, so we'll have the flag over the person. So the flag's measurements will always be in the numerator, the person's in the denominator. So the height of the flag is x. That relates to the height of the person, which is 6 feet. And then the height of the shadow, or the length of the shadow, is 15 feet. And the length of the shadow of the person is 4.5 feet. So now that we have our proportions set up, we're going to cross multiply. So we have 4.5x equals 6 times 15, which is 90. And we're going to solve. divide by 4.5. And that is x is equal to x is equal to 20. So that means that the flagpole is is 20 feet in height. So the shadow method would be useful for finding heights of really tall objects outside that you don't know the height of. So like the height of a tree or a house, something along those lines. So here's another problem with a tree and the shadow and finding the height of the tree. Why don't you pause the video and try this one on your own. Okay, let's see how you did. So we have a 6-foot person and they have a shadow of 5 feet. So here's the person and the person's shadow. So the person's shadow is 5 feet and the person's height, is 6 feet. I should probably make the shadow a little shorter in this drawing. Then we connect that together and we make a right triangle. A nearby tree, so here's our tree. Has a shadow of 30 feet, so that's a lot longer. And what is the height of the tree? So we want to know how high is the tree from the top all the way down to the bottom. That's what we're looking for, x, and this makes a right triangle as well. So we can have our proportions set up, the person over the tree. So what is the height of the person? 6 feet. What is the height of the tree? X. We don't know that. And we go back to the person. What is the height of, or the length of the shadow? It's 5 feet and 30 feet. So we have the actual heights here, and we have the shadows here. The person's always in the numerator, the tree is in the denominator. So now what we need to do is solve this proportion. So we cross multiply and set the cross products equal to each other. 5x is equal to 180. We divide by 5. 5x divided by 5 is x, and 180 divided by 5 is equal to 36. So that means that the tree is equal to 36 feet. And don't forget to write the units on the end of your measurements so we know what they mean. That's it for today. Thank you.